briefly.
Okay.
So without further ado, we're going to let Jeremy do our thing.
So today, I was going to talk a little bit about pen testing in the client applications. So web apps, typically when you do the pen testing, you're doing it against the server side. And based on a talk actually given here last month, Tom and Eston got interested in looking at this a little bit closer, and I have noticed that some of these topics are already starting to come up in web applications, especially ones that are developed for mobile. So basically, I was going to look at web storage, Ajax, and most of this is going to be demonstrations because it's a lot easier to understand hands-on than it is to just look at slides or read the RFCs. So web storage, just as a background to help with the demos, is the newer version of storage in the browsers on the client side. Cookies is the existing implementation, and they're going to hang around. Web storage is somewhat like a collection of cookies. It's like you can have lots of cookies. The collection is somewhat smart. It can tell you how many things you have in the collection. Cookie can't really do that. And it can hold a lot more items and a lot larger items as well. The browser will allow you to store a pretty good chunk of memory disk space. And with cookies, it's fairly restrictive. So the collections are kind of like cookies in that there's the session type, and then there's what they call the local type, which would be sort of akin to a persistent cookie as well. So the connection is pushing it a little bit, but that is kind of how it works. So with web storage, there is some good news. They do follow the same origin policy, just like a cookie does. In fact, it's really very similar in that respect. And there is, even though the limit is higher than cookies, there is a certain amount of disk that the web browsers are supposed to use and no more. But the browser is allowed to ask the user to increase that limit. With cookies, you can't actually increase the limit that I know of. It's pretty well hard-coded in. So session storage is allowed to live beyond the end of the session. As odd as that sounds, that's exactly what the RFC pretty much says. But Firefox and IE do respect the concept of session when you close the browser. All the tests that I did, the versions I did, the session version of the storage was cleared out. So the bad news is that all the old attacks that have been around for years work just as good against web storage as they did against the cookies themselves. And the web storage has no concept of like an HTTP only, and there's no concept of like a path attribute. So if the site does end up with some, like, say, cross-site scripting, it's going to be pretty hard to defend the web storage. The other items I've noticed, just working with developers one-on-one, looking at different projects that use web storage, especially, like I said, mobile development. Developers kind of think because it's a new technology that it's safe to use because nobody will be able to figure out how to take advantage of it. And there's no way to really do anything with it because it's too obscure. But obviously if the developers can use it, everyone else can use it as well. So that doesn't really hold it up. And there's no concept of sensitive at all. It's you put data into this web storage, and it is whatever it is. The browser has no way of knowing whether that's sensitive data or not. It doesn't look for credit card patterns or social security number patterns. It doesn't care. Everything's just a big string. There is no data type either. If you put something into web storage, regardless of what it looks like, it may look like a number, but everything is a string. So, on the Ajax side, some of the background information I wanted to cover was about the JSON data format, which is nothing more than a way to structure data that you're going to send back and forth between the browser and the server. It's one of many ways that you can structure data. XML is very popular as well. And basically, JSON is meant to be a little less wordy than XML. It's not tag-based, so there's not the concept of having to have an opening and a closing tag that adds bloat, some would say. But JSON is hierarchical, just like XML, where you start out with a root element, and then that element can have children, and those children elements can have, children as well. So it's nothing more than a way of passing data back and forth. It's analogous to a developer perhaps passing a common delimited list, for example, when they first start out, and then working their way up to formats that can handle more structure. So moving on to the demonstration. So we're going to use Burp Suite as a tool between the web browser and the web server. And the reason we're going to do that is that when the web browser sends the request, we'll be able to look at it and trap it and see what it looks like without it flying past too fast. Then also, when the response comes back from the server, we'll be able to look at that response before the browser gets a chance to render it into a picture on the screen. So I have some links that I'll give out at the end, and we're going to use a tool called Matilda, which was originally created by Adrian, and it's been enhanced into a version 2 with some new updates. And the channel that we send out updates on to let people know is a Twitter account down here at the bottom, so I'll pass that out to you as well. So we have Matilda installed as a web server and a virtual machine to make it relatively safe to mess with. And we have a Firefox web browser that's connected to a copy of the Burp Suite that will intercept the request and the responses. And I wanted to cover the JSON injection first, and we'll use that information to build on when we look at the HTML5 storage. So this page here is a pretty simple page. The way it works is you can pick a tool out of the list. So say like Skipfish, and then you say look up the tool, and it'll display information about the tool on the screen. And then you can also say show all and look up, and it'll just get a whole list of them. So as you can imagine, that we pick something out of the box and then we send it across the wire to the web server, and the web server has a query that says, get the tool 1 or just get all of them, and sends that information back to the page. And the way it sends it back is using the JSON, so we'll look at that a little bit closer. So the first thing we look at when we're doing a pen test is we need to know what the inputs are, because if you're not sure where to send the data in, it's going to be pretty hard to get any of your code into the system. So let's take a look at that first, and I'll turn the interception on. I kind of purposely chose a drop-down box because I've run into some conversations where developers thought, well, how can anybody pick anything that's not in the drop-down box as a drop-down box? And all you can do is choose one of the items. There's no way to inject anything in. But what happens is when we have a proxy sitting between the web browser and the web server, we can actually change the request in any way we want. So our goal right now is to figure out what the inputs are. Manually looking at this, you can kind of tell that that's an input, the page, and then there's the tool that we picked. We picked the 6th one in the list. And then that button we clicked is an input as well. And there's also a cookie. Burp Suite is kind of neat because it'll sort of point it out to you. You may have noticed that all the input parameters are blue and all the values that they have are red. And it even makes it a little bit easier if you say send this request to the intruder, which is this tab over here. And then click on the positions tab. You can see it actually makes it really super obvious. That's kind of neat. So instead of letting tool 6 go across the wire to the web server, why don't we change that? So I'm going to type in the value canary, just so it's aware that we know is not a number, and we know what it says. It's just anything arbitrary that we'll be able to identify. And then we're going to forward this request to the server, and it's going to look up in the database for a tool. It's probably not going to find one, I would imagine. And we can look at this response a little closer by typing in the word canary. And sure enough, it is in the response. And we need to pay particular attention to where in the response it ended up. So in this case, it ended up in some JavaScript. You can see that there's a start tag right here. Starts the script. And then there's a declaration of a variable called pentestable JSON. And then you can see there's this word canary that's kind of in the middle of that. So this stuff here, this stuff right here, this is the JSON. And it's the information coming back from the server. Now, another way to look at this, go ahead and forward this to the web page. And of course, there's no full canary, so it's not displaying any information. But another way we could have looked at this is we could have said view page source. The new Firefox makes you resend the request, so if you're using Bird, you'll need to replay that. Forward again. And then here's the source. And we'll just do Control F to find the word. And it's pretty much the same thing. So this web page might have a vulnerability. It's already failed the first test, and that is whatever the user sends in is reflected back. Okay? That could happen in a couple of ways. It could be whatever the user sends in is stored in the database, and then later on it's sent back. Or it could be that whatever the user sends in is immediately reflected back, like in this case. That's not necessarily a bad thing. It's just a red flag. It's perfectly okay to have that behavior. So we'll go on to the next step. So the next question is really, is the input encoded? In other words, if we send in, the output encoded. If we send in special characters that mean something to the browser, when they come back to the browser, are they rendered on the page as a picture like they should be so that we can see them and look at them? Or will the browser get confused and try to actually execute something? Look at another example, and I'm just going to send in some brackets and maybe some parentheses and just some kind of random characters, but some characters that might mean something later on. We'll forward that on and let's see what the server does. I'll use Control F and the tool, and here's that position where that canary was. And we can see that these are not output encoded. So what output encoding means is instead of displaying literally the brackets and these other characters, the browser should be presented with like the HTML version of them or the hex encoded version of them. The encoding tells the browser no matter what it actually thinks it sees right there, it should just display it on the screen and not execute it. If these characters are not encoded, the browser could get confused about whether this is information or whether this is something to do. In other words, code to execute. So the fact that the web server reflects the information back is not necessarily that big of a deal, but it is getting to be a bigger deal that the information is not coming back encoded. Now, to actually do an injection, what we need to do now is look at the context. So make sure I have this turned on. Forward the word context to the server, give us something to look for. What I mean by context is oops, probably shouldn't double click that. Okay. You see where the so-called payload landed. It's in the middle of a JavaScript string. Here's the declaration of the string, give it a name, there's an equal sign, and then there's this JSON. And it ended up right in the center. So in order to get something to execute right there, one of the things we need to try to do is we need to try to correctly finish this JSON right here. And then we need to try to figure out a way to get rid of this other stuff. Because if we stop the JSON here, if we finish that thought for the server, and then start a new thought, which will be our code, we're still going to have this stuff on the page, and that could mess everything up. It could break the page. So working backwards, we can see in order to close off this JSON, even if you don't know a lot about JSON, you can kind of sort of look at it and figure it out. We need to close off this double quote right here. And then before that, there's a curly brace bracket right before the tool ID requested that we need to close off. There's another curly brace bracket before the word query that we need to close off. And there's that opening parenthesis that we need to close off. So if we were to correctly finish that thought, we could still allow the variable pen test tools to be correctly created. You know, it won't have a very informative value, but at least it'll be syntactically correct. Then we can attempt to put a new command where the word context is, and we just need to figure out a way to get rid of the rest of the stuff. So looking at the context where the payload lands is really important. If it had landed in the middle of HTML, we would need to use HTML. So we're going to work on closing that out. And I brought a cheat sheet because demos never go right. So I'm cheating, I admit it. Okay. Let's try something else. Oh, I never actually let this go back to the browser. How about if I just drop that request and we'll just make it go. Okay, so we have our request again. Now this time, we're going to close off that bracket that was after the name of the variable returned. And then this closes off the bracket that was before the word query. And this paren closes that original opening paren. I think I forgot to mention there's the double quote that closes off the double quote that we were at. So it's a little harder to see, but that %3b, that is the URL encoded for the semicolon, because the end of a JavaScript statement should have a semicolon at the end of it. And so hopefully this will complete the thought that the web server had to make that variable, and then we can start a new thought. And what we're going to try to do is we're going to put in a simple command, alert1, which should just pop a little dialog off that says 1. And then we're going to close our statement with our own semicolon, %3b. And then we're going to put 2 slashes, which is the comment character in JavaScript. So what we hope the comment character will do is to comment out all that stuff that was at the end of the statement that we don't want to mess with. So let's forward this on. And this time we'll search for the word alert. Okay. So the pen test tool JSON variable is declared. And you can see that the characters that we sent in do seem to correctly close out the JSON. Even has a nice semicolon at the end. And then there's our command, the alert1 statement, with its semicolon. And then there's the comment symbol, which should get rid of that stuff that's on the end there that you see. And the stuff that continues breaks down to the next line. So we'll forward this to the browser. And there is the pop-up box. So it did correctly execute the intended code, except the variable, then it executed our code, and then it ignored that leftover stuff that was on the backside. All right, so what can we do with this? The problem with a lot of the reports that are given to developers and management is they kind of stop right there. So they prove that this is definitely a problem for sure, and oh look, we can pop up all these annoying boxes that'll break your company, right? No, it's like pop-up boxes do nothing, right? They're just annoying. Maybe you could serve an ad or something, I don't know. But, you know, at that point, management's got to be thinking, so what, right? So it's better if we take it a little further and create some benign demos that can be used to show the actual problem. So we'll up it a little bit here, and what we're going to try to do is we're going to try to get this web page to send the session cookie off to another web page that we control. So one of the things that we did is we created some new pages in Matilda, a lot of new pages, but this is one of them. And the way this page works, it's called Capturedata.php if you download the project, which is free and open source, by the way, so have at it. And it just basically explains what it's doing, and then it tells you, hey, the data captured is this stuff here. Now, I browsed to this page on purpose, so it's not a hack. I went to it intentionally, and it captured my data. And then there's a link to another page called Capturedata with a D. And on that page, it simply explains what it's doing, and it displays a table of the stuff that it captured. So some of the things that we can get are the, sometimes we can get the host name, we can get their IP and their port that they responded on, and we can get their user agent, which is sometimes useful. Of course, they could be faking that, but usually it's right. We can get the page that they came from, so if we poison multiple pages, we know which one they actually tripped over. Obviously, the data is important, and the time that it occurred. Okay, so now that we know that page exists, let's see if we can use that page. Oops. Let me turn the intercept off for a second so we can get back. Okay. So what we're going to do is we're going to change our payload. Now let me show you the payload before it's obfuscated with, because when we need the URL encode payloads when we send them so we don't break the web server. You know, if you send certain characters across the wire to the web server, it's not going to be able to parse the request. And we certainly want it to work. So unencoded, this is what it looks like. We close off the JSON like we did before. And then we start a new command, document.location equals the URL to the capture page, and then it tacks on the cookie. And then we still need to include the little trailing comment symbol at the end to get rid of that other JavaScript that we don't want to execute. I'm going to copy the encoded payload. The place I'm copying all this stuff from is a special file in Matilda called test scripts. It's kind of sort of hidden on purpose to give people a goal to go after. So if you download the project, there's about a dozen different ways you can figure out where it is and get it, including command injection, directory browsing, all kinds of ways. So if you do download the project, see if you can find it. It's got some pretty good stuff in it. So, all right, so we're going to, oops, got to turn the intercept down. Didn't hear us. Okay, so we'll look up Wrinkle Scan. We're going to paste the prefix, the payload, and the suffix, the comment symbols, and then forward that to the browser. Instead of hitting forward, I'm just going to turn the intercept off, and that lets everything from here out flow through the Burp Suite so that we don't have to keep hitting forward. Okay, now actually click back almost soon enough to where we can see we came back to our pen test tool page and we got redirected over to the capture page. The data capture page grabbed our cookie. It now has our session ID. So with a tool like Cookie Editor, we could simply paste that session ID into our browser, hit F5 or browse to the site, and we would be logged in with them, right? So because you don't need a login and a password to log in, you just need either the login and password or you need one of their current sessions, and you're in. So this is particularly dangerous in unencrypted radio networks. Let me see if I can get back to the page we were on, turn the intercept off. Now the problem with that is, may or may not be obvious, but if you're a user and you're using a website and all of a sudden you end up on some other person's website and you didn't click anything, that's probably a red flag, right? So the user might be thinking something at this point like, that ain't right. I don't know what's wrong, but I'm calling tech support. You know, of course, the sad thing is some wouldn't, but
Yeah.
anyway, moving on. I don't want to start a war here.
I'd say it's on the high side.
Could be. All right, so let's look at maybe a little bit better way of doing this, especially if you want to, do a good job for your client. And also, like we talked, our goal again is, well, my goal is not to hurt the site or do anything bad to the site. The goal is we want to show that not only is the defect credible, which the alert box did, but we also want to show, without hurting anything, that it's dangerous. And we want to do it in a way that's simple enough that it's pretty obvious to ordinary users that this is a bad thing to happen. So this next payload is one that I built last week and put in Matilda, and it has the prefix, the same one we had, and the same suffix. But it has a little bit of a different payload. And I think I have a copy at the bottom we can look at. That's a little easier to read. Not much easier, but a little bit. It declares essentially a XML HTTP object, which is able to send web requests in the background. A lot of people call this AJAX, but since a lot of people don't use XML anymore and they use JSON, I don't know what the acronym would be. It's called Web 2.0 sometimes, and mobile apps tend to use it a lot because you don't want your screen to change. You just want to like fill in the screen with little bits of data and stuff. So if you're ever on a web page and the page you stay on that page without refreshing or anything, you just stay on that page, but the page keeps changing and getting data from databases like Google Maps, something like that. That's probably an AJAX page. It's probably sending web requests as if you had typed in a URL and hit enter, but it's sending them automatically, and these objects can do that. So it declares one of these gizmos up there, and then basically what I did is I put a template in here so that depending on what page you're working on, you can just kind of fill in the Matilda blanks and make it a little bit easier. So this is for GET requests and this is for POST requests, and we made one for GET. And we kind of Matilda in what we needed for this demo. So if this object is capable of making a request in the background, then that'll get rid of that problem where we actually went from the user's page over to the capture data page. And it may not be as obvious that something bad happened. Now it's still going to go to the same capture data page, and it's still going to do the exact same thing, which is take the cookie. You can kind of see the URL right here, Matilda capturedata.php cookie equals document.cookies. And I'm going to turn off the intercept. And if everything works well, it should look pretty normal. Now the one thing that's a little maybe a tell is none of the data came back. So we probably need to adjust our payload a little bit to make sure that both data is returned and it fires off of our XML. Maybe if we did a better job of completing that JavaScript with the prefix instead of just closing it off, if we had actually filled it in with some data, it would have looked a little bit better when we came back to this page. But as you can see, it doesn't look like anything really happened. Now, I'm going to change the request a little bit just so we know that something actually did happen. And do it again. Just so that we know that something did happen, I'm going to add an extra parameter up here called test. Give it a value and then forward that on. Because the capture page captures GET, POST, and cookies automatically, plus any payloads that you send. So let's browse over to Capturedata page, excuse me. Let's see, and I think this is the last one we got. Unfortunately, the cookies all kind of look the same, but that's pretty much it. And I'm going to try it one more time because I didn't see that little extra character that we sent in. Okay, so this time I left Burp running in capture mode, and you can see that it did indeed make a request to the capture data page in the background, and then the capture data page is going to come back, and that should be the end of it. So it looks like it is working pretty well, and now there should be even more of these captures in here. So it's grabbing the cookie and log it in there. So that one worked pretty well. Now, as far as the HTML5 web storage goes, we can kind of build on this and see how this storage might be a problem. So we have basically a page that just declares some HTML5 web storage. It declares about 5 items, and then it displays a couple of them. There's a reason it's not displaying all 5, and that's one of the challenges to this page, is to figure out how to get the other web storage items out. So when you download the project, there's you can hit toggle hints, and there'll be these sort of pink boxes that pop up, and they'll actually explain everything and tell you what the objective is and tell you how to do it. We're going to turn that back off. So you can imagine the web developers put something into the storage that shouldn't be in the client side. It could be authorization tokens. It could be information about the client, like maybe some report items that they looked at. There could be just about anything they're going to put in there that's not appropriate for web storage. So web storage is a good location to store things that don't matter, user preferences, maybe non-sensitive items of the user profile, something like that. But it's a really bad place to put anything that matters. So this is how they would set that. And then what we're going to try to do is we're going to try to figure out if there's a way that we can read that web storage out. So it turns out there is. We can do it the exact same way the developer does it. We can use the API. So the API that is given with browsers basically looks like this. You can look at some attributes, but there's a function called getItem and there's a function called setItem. So the developers are going to set it with the setItem, and they're going to pass in the name for this thing they're storing and the value of it. The name is called a key. And then we're going to use the getItem to get them back out. Now, there's no way to really stop this, because if the web storage is in your browser and the browser's on your computer, you can control it. So there's no way the developer can really stop you from looking at this. Okay, so we're going to use the same exact method we used in the earlier example. We're going to use a cross-site script, but instead of injecting into JSON, we're going to inject into HTML. Since we're going to be injecting into HTML, we need an HTML tag, because it's HTML context. And so we're going to use a script tag to start, and then that'll allow us to put some JavaScript inside of the HTML and get it to execute. Okay, so we're going to skip the phase where we look at the inputs and figure out which one's vulnerable and figure out if it's encoding characters or not, and figure out if it's outputting on the page. And we're just going to pretend like we already know that this page has displays the user agent at the bottom. see it displays the user agent at the bottom here. But it fails to encode those characters when it displays the user agent. Now, the user agent string is controlled by user, so that's us, and we can control that. So we're going to paste that script that reads the values out using the get into the user agent string, and then forward that. And as expected, if we look at the bottom, where the user agent string goes, the page puts the information out, and then there's the script. And then that script probably will run because it's a valid HTML tag with a valid syntactically correct JavaScript in the middle of the tag, so browsers do what browsers do, and they just execute it. So developers might have thought that the user agent string was something to show on the screen. However, if we change it to something to do, the browser will do it. And sure enough, it did. And because we don't have any restrictions on what we're reading, we actually got all 5 of the web storage items back out. Can anybody tell what the developer did to keep them from displaying normally on the page? There's something special about 3 of them. I'm sorry, I can't do the Zoom thing when I'm in pop-up box mode. So. Oh wait, yeah, I can. Let's try harder. So if it doesn't work, hit the key harder. So.
You cleverly named them secure.
Very good, yes. And then the JavaScript, as you probably anticipate, says, hey, if it starts with secure, don't show this on the screen. So you might laugh, but this is the kind of stuff I see. Like, this is sort of the mindset. If you can't see it, it's secure, right? But you have to carefully explain that just because you can't see it in the browser window doesn't mean you can't see it. You can see it going across the wire. In other words,
Doesn't mean it's not there.
doesn't mean it's not there. So, all right. Well, again, that was a fun pop-up box, and that actually could be useful. If a developer puts stuff in web storage that they never intend the user to see, and you're the user, and now you know that you can see anything you want, anytime you want, that could be a problem, right? So, even if you're not a web developer or even worried about any of this per se, just be aware that whatever you put in web storage belongs to the user. You gave it to them, and if they want to read it, they can. So you need to be aware of that much of it. All right, let's keep going. Okay, now again, we're doing stuff, I guess you would say we're doing stuff to our own web storage. So we're not doing stuff to anybody else's at this point. So how might we add a value into the web storage? So let's say that the website uses something in the web storage for authorization of what you can do while you're in the site, and you don't really like being a user, maybe you want to be an admin, right? So maybe what you can do is grab this. Maybe what we can do is use the set. Remember the set item function that we looked at earlier was the one the developer used to set stuff in the first place. See, it's right here, set item. We can use that too and execute a set item statement to set the values. And then we're going to use the exact same script we just used a second ago to read them back out after we set it, because we want to make sure we did it. So we're just going to build on that example. And again, the mindset is you're the user and you just want to change the web storage. You're not doing something to somebody else. So I copied that. Need to refresh the page so we can capture it. We're going to do all this in the user ID again. Okay, so instead of sending in 2 scripts, I think we can probably just shorten it a little bit. Oops. Let me delete that. So now we have the script that does the local storage.set items, and we're going to set an account number equal to 12356. So we're going to set the enterprise self-destruct sequence to A1B2C3, and we're going to set a session ID, hey, why not, and put a session ID in there some session fixation perhaps. And we're going to say the currently logged in user is somebody else, and let it rip. Okay, so our second script, our original script, ran, and now in addition to the 5 items that we saw earlier, we can see that there's the account number and the enterprise self-destruct sequence, and the currently logged in user is now that user, whoever that is. So if the website mistakenly stores authentication or authorization tokens in the web storage, the user can simply change that to something else. Okay, so now we're going to change the mindset a little bit. Instead of you being the user and you're just changing your web storage to your benefit, or reading the web storage that maybe the developer didn't intend for you to read, we're going to look at trying to change other people's web storage. That gets interesting. Mainly because it works. That's the bad part. Okay. So one of the more basic forms might be just trying to read someone else's web storage. Let's see. Oh, I'm sorry, that's the proof of concept test. We can kind of get advanced past that because we already reviewed how the XML HTTP object works and how we can make this request in the background that you can't really see, but it doesn't change the fact that it happens. And instead of having the payload be that document.cookie thing, we're going to take our original script that read the HTML5 storage, we're going to shoehorn that into the script that sends the stuff across the wire to the Capturedata.php page and send it all in together. I guess you could say we changed the payload as a payload. Okay, so turn it off and go back here, and well, nothing happened, right? It actually did add those items that we added before and showed it on the screen, but we didn't see anything really get stolen. So probably what we need to do is go over to the Capturedata page and see if anything might have been stolen. And look at that. Oops. Sorry if anybody sees it there. So it took the HTML5 storage and it kind of bottled it up into a big giant string and shot it across the wire in an invisible request in the background, which ended up on this page. And all this page does is write stuff down on the screen, writes it into a file, and also writes it into a database. And we got their authentication token and their self-destruct sequence and all that stuff. All right, and one last thing. Let's say that the developer sets the value in advance of the web storage, and instead of adding new values, you actually want to overwrite the values that's there. So they may have, for example, going back to the previous one, they may have written that your authorization level is user 1, and you want to change that authorization level to user 2, or something like that. So to do this, there's already a, oops, sorry, I have to go back to the HTML5 page. There's already a message of the day on the screen. It was there when we came into the page originally. It says go cats, local storage. So can we change that message of the day to something else after it's already been written? Well, the way the API is defined, the set item function not only sets an item, but it can also change an item. There's really no edit item function or anything like that. The way it's implemented is if you try to set an item with a key that doesn't exist, then it adds it. If you try to set an item with a key that does exist, then it overwrites it. So it turns out that setting an item and changing an item are actually the exact same source code. And since we looked at it before, that we were able to set up this, it should work. So we know what the message of the day is currently. And I'm just going to shorten this up a little bit. We don't need 2 scripts. Okay. Okay, so let's see if we can find it. Yep, looks like it did overwrite it. But on the screen, it didn't actually change. Well, the reason is that we ran our script at the bottom of the page down here. We ran it after the original source code on the page that was supposed to be there had already written this stuff out to the screen, right? So we might have changed it, and we can verify that we changed it by looking at the little pop-up box. But what if we wanted to change someone else's value and also make it to where when they look at their screen, it changes without them being able to detect that it changes? It looks like it came from the developer original. So that's a little more tricky. The way that's done is you need to look at the developer's code and figure out what is it that they did to make their stuff display on the screen. Then when you inject your script, if it executes after their script, just call their script again. So their script runs normally, then your script runs, and then call their script after you run yours to get it to re-display everything on the screen. Hopefully that makes some sense. It's kind of confusing, but if we look at the source code of this page, turn that off for a second.
Won't that just reset the value back to their value?
Oh, okay. So yeah, that's a good question. So want to reset the value, right? So there's a difference between them calling the setItem function in JavaScript and then them displaying it on the screen, which is going to be just like some kind of loop probably or something like that, right? So we want to be careful to only run their code that display the items, not their code that set the items. So one of the problems there might be, let's say that all of that junk is in one giant, huge, massive, nasty function, which should never exist, right? But people do crazy stuff, so it could be one giant function. Just copy their portion of their code that does the display and rerun it. So you need to separate it out, of course. It'd be a bit more of an advanced technique, but certainly doable. Okay, so I'm going to kind of shortcut this a little bit because it's boring to look through the code. And it turns out that there's a function called init that you can see is what writes stuff out. And while we're here anyway, it has this if key.match starts with secure, don't write it out. So that's how that thing worked earlier. It's very secure. So again, if you're an auditor, if you're an assessor or something like that, it's not important necessarily to know how to replicate all of this, but just be aware that all of this is possible. And don't put anything in web storage that matters. All right, so let's see where we're turn that on. Grab our scripts that we already tried anyway, that worked a minute ago. Overwrite this area here, since we know that's the vulnerable area. Now this user agent thing is just for demonstration. You probably would find a better place to put all this in, but we covered that earlier. Okay, now at the very end, so I think they spelled it INIT, right? And then a little semicolon at the end. Let's see if we can get this to work. Okay, there's our pop-up box. Okay, there's the hello world. Now, what's interesting about this example is it's incomplete because there's all the stuff that they output when they call their function, right? And then we recalled their function again after we made some changes, and then it output everything again, but with our changes. So the nice thing about this page is you can see that it did change, but the bad thing is I think the user would notice that. So the next thing we would need to do is look at the API. And let's use the toggle hints because it's got the API in it. A little bit easier for us to see. there's a deleter function called remove item. So you could simply say, all the web storage that exists right now, just delete it. Or if you wanted to really do that, if you want targeted item, use remove item. If you just want to blow out the entire web storage, just call this clear function, local storage.clear, session storage.clear. Then it'll just blow it out, and then you can rewrite it, if that makes sense. Okay. All right, and that is the end of the demonstration. So go back to the home page here. Make sure this is turned off. Okay. So I did want to spend just a couple minutes talking about Matilda and what it is. It's basically a website. That's all it is. The difference is that it's really easy to install. You download a program called Xant, and you install that, and then you put Matilda in the htdocs folder. And there's installation instructions on Adrian's site on how to do that. So next question would be, where's Adrian's site? Well, it turns out if you just Google the word Matilda, spelled like that his site is the very first one that pops up, and you click on the link to irongeek.com, and it'll take you to the Matilda page. And on that page is a menu that looks a whole lot like that. Matter of fact, I think I just copied and pasted it, so it should look exactly like that. And there's one called installation instructions, and you click on that, and it's a PDF, I believe. Let's see if I can get it to work. Oh, wow, okay. Need more power. And it explains how to download the Xant and install it, and it talks about Windows 7 because there's all these pop-up boxes that occur and all that stuff. So, easy enough. So why would you want to install it? Well, what you don't want to do is install it on a production bot, for sure, because it is vulnerable on purpose. And what it does is it provides pages that give you all of these capabilities. This is the OAuth's top 10. And all of these items are in each of these pages. In addition, we've pretty much made it to where there's multiple items for each of the OAuth categories. So for injection, there's now about a dozen different kinds of injection that you can do. We covered the Json injection today. That's the one down here at the bottom. You can see it points to the pen test tool we looked at. So there's opportunities for the style sheet injection and the parameter deletion and JavaScript, and on and on and on and on. A lot of different kinds of SQL injection. And there's cross-site scripting, and it's got a lot of categories of those, and so on and so forth. In addition to the OAuth's top 10, there's this others that has vulnerabilities for file execution and different transport layer problems and denial of service and JavaScript security, right? JavaScript to try to filter things out. And the data capture pages that we already looked at. And then all the documentation is there. So if you want to have a site that's safe and runs on your own machine that you can practice doing the vulnerability on, this is one possible option. And there's some other options like OAuth's WebGo, the UWA. And if you get the Samurai Linux installation and install it, it has all of them already installed on there. But it doesn't yet have the current version of Matilda, so you would need to download and replace, rename his version, and then copy and paste the new files into the folder. So, all right, and we put updates to Matilda about once every 2 weeks on average. Sometimes it's a month, sometimes it'll be 3 updates in 3 days. Kind of depends on how much time's available. And we post the updates to the Twitter account, Webinized, and it's WBPWNINZED. So if you want to get the updates, there you go. All right, and that concludes the presentation. Thanks.